Okay, scholars, so this is like the payoff point of our work with fats, okay? We've been thinking about covalent bonding, and we've been thinking about fats. And so, this is covalent bonding part 5. Part 5, okay? And we'll call it a tale of 2 fats. Okay? So this starts to get really, really like fun and interesting. Okay, so the first fat you know, right? But go ahead and draw it anyway because you want to see it again fresh and you want to get that experience of drawing it again freshly into your notebook. And one thing that I want you to do, I want you to use the margin of your notebook, okay? Just that little left side next to the little line, right? It could be like a little light blue line or a red line, but use the margin for your questions, okay, as we go along. So sort of like a modified Cornell notes. And at the very end of lecture, I'm going to ask us to all write a little summary on what we've learned, okay, before we do our building process. Probably starting next lecture, that summary will be graded, okay? So it'll be one little thing that you'll turn in at the end of class to get credit for what you do in lecture. It's going to help your grade because everybody's taking notes, okay? So, okay, so we've got 2 fats that we know about. The first one's olive oil, okay, and that comes from plants. That's a plant fat, right? And you got your glycerol here. Okay, and then you go your 3 fatty acid chains that are bonded to your glycerol. Okay, and then you go 2, 4, 6, 8, 9, 10, 12, 14, 16, 18 carbons, and this little chain is oleic acid. Okay, and then here we've got 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 16, 18. This is linoleic acid. And then we have palmitic acid at the very bottom, so 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. Okay. And again, I always count because that's really, really important. We got to make sure we've drawn the right chemicals on the board, okay? So this guy's palmitic acid. Okay, palmitic acid, great. And then here's the other fat that we're going to draw today. And so this guy's crazy. This guy could be beef tallow, or it could represent butter, right? So this is obviously an animal fat. Animal fat. And you'd be surprised at how similar it is to olive oil. So, okay, here we go. So, okay. All right, so the first fatty acid in this thing is actually palmitic acid. So these acids are listed, they're like drawn on the board in order of percentage or prevalence within the type of fat itself. So this is palmitic acid. We go 2, 4, 6, 8, 10, 12, 14, 16. Double check. 2, 4, 6, 8, 10, 12, 14, 16 carbons. Very good. Okay, palmitic acid. Okay, and then we're going to go stearic acid. So you haven't seen stearic acid before, but it's actually just like palmitic. It doesn't have any double bonds, but it's got 18 carbons like oleic acid and linoleic acid, okay? So 18 carbons like these two, but no double bonds like this guy. So we go 2, 4, 6, 8, 10, 12, 14, 16, 18. Double check. 2, 4, 6, 8, 10, 12, 14, 16, 18. Good. Okay, this is stearic acid. Okay. And then the last one, believe it or not, is oleic acid. So same fatty acid chain we find in olive oil. 2, 4, 6, 8, 9, 10, 11, 12, 14, 16, 18. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18. Good. Oleic acid. Okay. So here's the thing, right? Like the crazy, crazy thing. This stuff, relatively speaking, is good for your health. This stuff, relatively speaking, is not good for your health. This thing here is a liquid at room temperature. This guy here is a solid at room temperature. That's crazy, right? There are these physical differences and biological differences between these two. And they don't look that much different. I mean, for crying in a bucket, they've got 1, 2 of the same fatty acids. So what are we swapping out? We're swapping out linoleic acid for stearic acid, right? So what in the world is going on? How can this be? For the sake of those who won't get to see, get to be here to do this, right? We've got a few people missing today. That'll be the case probably for the other mods. I'll go ahead and tell you what's going on. It turns out that these double bonds here and here don't actually allow these chains to be as straight as they're drawn. So these chains don't actually in real life look like I'm drawing them here. Okay, chemists need to approximate sometimes. So we represent this way so that we can sort of get a, like this gives you a really good sense of the length of each fatty acid, right? And it lets you see where the double bonds are very well. But what actually happens is these double bonds cause kinks in the chain. They cause deviation from like this straight appearance. So they cause bending, right? Like the whole chain is actually going to bend because of this. And you'll see that when you build these molecules. These molecules over here, this one not included, but these two, because these are called saturated fatty acid chains, and we'll start talking more about what that means in later lectures. Right now I want us to build, get to see these differences and like feel them with our hands as we put these molecules together. Then we're going to zoom in on these bonds at a later date, okay? But these straighter chains, okay, which we call saturated fatty acid chains, they can stack on top of each other very nicely. And because they can pack really nicely, they can actually interact with one another more strongly than can these chains, okay? So these guys stack on top of each other a little better. They interact a little bit more strongly. That means they have a higher melting point. So this guy is a solid at room temperature when room temperature is enough temperature to melt this guy. Now, if you put this fellow in the microwave, he'll melt pretty fast. If you put this guy in the refrigerator, he'll freeze pretty fast. But nonetheless, an observable, like everyday distinction between the two of them absolutely does exist. And it boils down to swapping out this guy for this guy, okay? Allows more stacking of triglycerides on top of each other, stronger interaction, means this guy stays solid at room temp, okay? And today what we're going to do is we're going to build these guys. This half of the room is going to build this guy. This half of the room is going to build this guy, okay? And we're going to lay them out on that back table where we usually have the robotics, that big one over there where the two tables are smushed together, okay? We're going to lay them out there and look at them and examine their differences, all right? So, that's our assignment for today. Good luck. May all of the forces be with you.